Centripetal force means center seeking. For objects moving in a circle, there is a net force acting towards the center which causes it to seek the center.
So in this first situation of centripetal motion, we look at a ball hanging from a string that's attached to a ceiling, and then we'll observe what happens in the acceleration of the ball when it experiences the half-parabolic circular motion. So as we see this ball move along this path and observe the forces acting on it, we know that the downward force of gravity is present, and then we also know that the upward force of the rope pulling on the ball is also present. So when we look at these forces together and we think about the idea of centripetal motion, we know that the acceleration of an object in circular motion will always be towards the center. So if we see the ball moving around in this sort of motion back and forth, especially coming from this central spot right here, we know that its acceleration is going to be upward towards the center of its circular motion. And if we want to look at an equation to resolve the motion of this object, we can come from the equation force equals mass times acceleration, going to the net force on the ball equals the mass times the centripetal acceleration. In this second example, we're going to be looking at the motion of a tether ball around a post. Going around. Alright. We're going in that direction. Okay, so with our tether ball here, we can look at this event in a few different ways. We can look at the centripetal acceleration of the ball, we can look at the forces acting on the ball, and then we can look at the resulting net force on the ball. So first, we know that gravity is going to be acting on the ball. So using a free body diagram, we can see that force gravity is acting on the ball, as well as the tension of the rope pulling on the ball. Now, we know that the acceleration of the ball at this point is going to be left towards the center of its motion. So that means the resultant force of our ball has to be to the left as well. So if we want to find the resultant force of this situation, we can split our free body diagram into x and y dimensions, and then we can solve for the missing component making a right triangle. FAY and FAX. So we know that the y dimension of FAY is going to be canceled out by the gravity, so we're left with the resultant force of FAX. So if we're to look at this in a force equation, we know that the net force is going to equal mass times acceleration. So then we can then derive that FAX is going to be equal to the mass times the centripetal acceleration in this situation.
Objects in motion tend to stay in motion with the same direction and speed unless acted upon by an unbalanced force. Moving objects will tend to naturally travel in straight lines. An unbalanced force is only required to cause it to turn or change acceleration. Thus, the presence of an unbalanced force is required for objects to move in circles.
Let's try acceleration towards the center.